Olivia, will you come up to the front of the class, please? Shake this up as fast as you can. Get it really mixed up. Beautiful. Alright, now hold it up so we can show the class what's happening. Dana, will you describe what's happening as we go?
The colors are separated.
Great. Let's watch it a little longer. Oh no, what's happening here? And at the bottom.
Filling with water.
Right,
So you get closer together.
Excellent. So we have something is separating out, causing the beads to come together. The whites are all together, the blues are all together. Excellent. We watched a little longer. Pretty soon they come to rest. Right there. Pretty cool, huh?
Yeah. That is cool.
Alright, you guys can come up and use this at my desk at any time, but we'll wait till after class. So today we're talking about density. We're going to talk about what it means and how to measure it. So, if you guys will all grab your pencils and paper, we're going to write down the definition of density. Density is how compact an object is. Because density is the ratio between mass and volume. So, mass is how much matter is in an object. Perfect. Got that down? So our mass always stays the same. Can anyone tell me the difference between mass and weight? Is there a difference? That's a hard question. Good. So if we send Dana out to the moon, we put her in an oxygen suit so she doesn't die out there, and we let her go all the way out to the moon, she's going to weigh less on the moon than she's going to weigh here on Earth. If we put her on a scale and have her weigh herself here, she's going to weigh less on the moon than she would here. However, her mass never changes. Her shape and her size are going to be the same throughout her whole time, whether she's on Earth or in space. Okay? So, our next definition is volume. Volume is how much space an object takes up. So, if we have 2 Kleenex boxes, would you say that these both have the same volume? They're both the same exact shape. They look like they're the same dimensions all the way around, right? But, Dana, will you come up and hold these up for me? What's the difference in there?
This one's heavier.
This one's heavier. Great. All right, so we're going to measure, thank you, we're going to measure the density of these 2 Kleenex boxes. Now, density is the relationship between mass and volume. So write this equation down. Density equals mass divided by volume. We want to measure mass in grams and volume in centimeters cubed or milliliters. Okay? And the difference between milliliters and centimeters cubed is that if we're measuring a box, for instance, we're going to be able to use a ruler to get the dimensions of this, right? Who can tell me how to measure volume in a cube or a rectangular prism?
Volume, length times width times height.
Excellent. Length times width times height. That's right. But if we have an object such as this, there's no way you can't grab your ruler and figure out how many centimeters that is, and then, oh no, you have a hole in the middle, you've got a hook on top. So there's no way that you're going to be able to measure the volume of this using a ruler, using centimeters. So that's where we're going to use centimeters, or that's where we're going to use milliliters rather than centimeters cubed. Alright, so yesterday we talked about how to use a triple beam balance to find the mass of the object. Okay, so our first step in finding the density is to find the mass of the two objects. Okay, so will one of you measure the mass of this box and one of you measure the mass of this one? Make sure it's set at 0, your lines lined up before you start. Okay, great. How much did you measure?
183.25 grams.
183.2.
Yeah. Perfect. So 183.25.
183.25.
Yeah.
All right, mark that down. Dana, set the triple beam balance back to 0.
That's
And put
grams,
your-
right?
Yep, and we're measuring it in grams. Slip it on there. That's the lighter one we have, Dana? All right.
It's almost perfect. 37.015? Wait. It has to be 15? Yeah.
37.15 grams. Excellent. Mark that down too. Make sure you know which one was your heavy and which one was your light. So make a little chart on your paper.
Just wrote it plainly.
Good. And once you have that, we're going to measure the volume. We're going to measure how much space they take up. So we already established that these two boxes are the same volume, right? So we're just going to have you measure one of them.
Okay.
And what units are we going to use again?
Centimeters.
Centimeters. Excellent. We want these in centimeters cubed. So go ahead at your station, find the length and the width times the height, and write down
Oh gosh. Okay. That's
length.
$1.75, I think.
Right?
Yeah. So 12.75.
12.75
That's the height.
is the height. Great.
And then 11. Yeah, 11 for the width and 11 for the length.
11 for the length, 11 for the width.
Yeah,
And we're in centimeters, right?
centimeters.
Excellent. And then on your calculator, will you calculate that out for us? So length times width times height.
Yep. I got 1,542.
1,442?
1,542.
Oh, 1,542.
1,542.75 centimeters cubed.
Great job with your units. Now what's our last step to measure to find the density?
We divide those.
Divide those. Excellent. Mass divided by volume. Plug those into your calculator. We're going to do, which one are you going to do first, the heavy or the light?
The light.
Do the light one first. Alright, so we're going to do 37.15 grams divided by the volume of the box.
Okay. Ooh.
And that's in centimeters cubed. And what did you get?
0.024.
0.024.
Unless you want me to keep going.
No, that's perfect. That's enough. Yeah. From what we can get, that's
Okay.
perfect. All right, and Olivia, do you want to try the heavy box?
That's 0.119.
0.119 grams per centimeters cubed, right?
Yeah.
Make sure you always label your units. Don't forget that. It's very important. Alright, so which one of these has the greater density?
Heavy one.
The heavy one, right? That makes sense because there's more stuff in the volume.
Yeah.
Right? There's more matter in the volume. Okay? Alright. You guys are doing great. Next, we're going to do the water displacement method. Because like we said, with these, there's no way that we're going to be able to measure the mass using a ruler, right?
Mm-hmm.
So, what we're going to do is we're going to attach this hook to this string. Right now, we always want to measure the bottom of the meniscus. So the meniscus is going to make a little U shape. So it's going to be, you're going to have your beaker here, and it's going to make a little U shape because the properties of water tell us that the water is going to ride up the sides a little bit. Okay? So we want to measure the bottom of the meniscus. Okay. So right now, will one of you girls tell me how many milliliters of water is in there?
Wait. 800, 870?
870, perfect.
Like,
Alright, mark that number down on your paper as the initial water volume.
What did you say, 870?
870.
Milliliters.
Milliliters. Because milliliters is what we use to find the volume of an irregular object. Because we're doing a water displacement method. Okay?
Mm-hmm.
So, what we're going to do is we're going to take the string, we're going to attach it to one of our objects here. We're going to loop this around our finger so we don't drop it all the way in. And we're going to sink it down, and we're going to see how much the water rises. We're going to find the final volume of the water. Okay? And that's going to tell us the volume of this object. Okay? So, go ahead and do that. There you go. Have it all set up for you.
Okay. It's 900.
900. Okay. Mark that down on your papers. Excellent job. Okay. And we're going to do the same thing.
How do we
With
label
this
this
one?
one?
You could call it gold, you could call it bronze. This one looks a little smaller than the other.
Okay.
Label it enough so you know what it's talking about. Okay? And then you'll dip this one. Perfect. We're going to make sure we get these nice and dry before we put them on the sugar bean balance to measure the volume.
910.
910.
Yeah.
Alright.
Is that like an angle? Yeah, I would say 910.
910. Here you go. Dry it off on that sheet. Olivia, do the honors of measuring the mass of that one. If you read the label, it's going to tell you it's about 200 grams, so you can kind of assume, but it also has a little extra coat on it, so that's where the different values will come from. You can see the black one is chipping a little bit. After you guys do this at your stations, we're going to go around and do a lab of rocks, so you can tell the different densities of rocks.
Yeah, like 200.1, but yeah.
200.1.
Yeah, grams.
All right.
That's the whole one.
200.1 grams. And we decided the volume on that one was the water final minus the water initial. So it went from 900, or went from 870 to 900, right?
Yeah.
So take 900 minus 870 to give us 30 milliliters. And then do the same thing for the black one. It's going to be close to 200 as well, maybe a little different.
Oh, it is.
Olivia, did you calculate the volume for us of the black one? Went from the water displacement, went from
910 or 870 to 910, so that's a difference of 40.
Good job. That's 40 milliliters. And Dana, when you get the mass, let us know.
Oh man. Okay. 199.5. No, 0.6.
199.6.
7.
Right, 0.7
199.7
grams. Okay? To find the volume, or to find the density, what are we going to do?
Divide the mass by the
Mass
volume.
by the volume.
So the gold one is 6.67.
6.67. What are our units?
Grams per milliliters. Yeah.
Good. And then the black one?
No. 4.9925.
4.9925 grams per milliliter. Right?
Mm-hmm. Yeah.
So even though these two objects had almost the same exact mass, because their volumes were different, it changed their density. Right? Mm-hmm. So we learned that the gold one is more compact for its size. Right? Has more stuff in it for its size.
Yeah.
Okay? So density, overall, just like we showed with the beads, can describe a lot of features here on Earth. Like the reason we worry about oil spills is because oil is less dense than the water. So that means, like we have the beads here, if the white represented the oil and the blue represented water, the oil is going to sit on top of the oceans out there. Okay? Same thing. Who had a birthday recently? Anyone?
Me?
Yeah, good. And you got helium balloons, right? What happens when you let a helium balloon go?
It floats up.
It floats up. And why is that?
Because it's less dense than air.
Great. It's less dense than the air around it. Perfect. You guys are becoming experts. So as we go through the rest of the class, we're going to do a lab. You have stations set up around the classroom, and you're going to go to each station and your partners and find the density of different rocks and materials on Earth, so that in a few days we can learn about plate tectonics and why certain features are the way they are here on Earth.